Now we come towards the defects of vision. However, the basic defects of vision are myopia, the hypermetropia. Myopia means the short-sightedness. Hypermetropia means the long-sightedness. And then comes the presbyopia and astigmatism. In many of the cases, we use the convex lens. Otherwise, we can use concave lens. So, myopia is that particular defect in which the image of the object will never come exactly to retina but slightly before the retina. To correct it, we use concave lens. Similarly, in hypermetropia, we find that the image slightly goes away from the retina, so we use the convex lens and it gets converged on the lens, that is on the retina, and we can clearly view. Similarly, in other two defects, we use bifocal length, that is the lens must be cylindrical. Now we come to the main concept. So, regarding eye, it is observed that in eye, convex lens forms real, inverted and diminished image at the retina by changing its convexity, that is the distance between the eye lens and the retina is fixed, that is never changing. The human eye is the most sensitive to yellow-green light, having wavelength of 5500 angstrom unit. However, it can vary up to 5800 angstrom unit at least, and it will be to the violet side. It is 4000 angstrom unit, and red that will be 7000 angstrom unit. The size of an object as perceived by the eye depends on its visual angle. That is, at what angle we are viewing the object, that is called the visual angle. When object is distant, its visual angle theta, and hence image I1 at retina is small, and it will appear small, and as it is brought near to the eye, its visual angle will become theta naught, and hence the size of image I2 will increase. That is, image will become magnified. Now, the two figures are shown here. Right in the left side, the figure is in which the visual angle is theta. Object is situated at O, and x is the distance of object from the lens. In the most important conventions, this distance can also be conveyed by u, and if the image distance we have to see, it will be conveyed by v. So we are finding if the object is O, its image will be I1 and the visual angle will be theta. Now we come towards the right side figure. In the right side figure again, O is the object, and I2, that is the ray of light is coming from the tip of the object, and it will be inverted image. Visual angle is theta naught in both the cases. They are the vertical opposite angles geometrically. And D is the least distance of distinct vision. So object is placed from the convex lens, that is about distance D, which is 25 centimeters from the convex lens. And the next thing is, the far and near point for the normal eye are usually taken to be infinity. That is called the power of accommodation. And 25 centimeters and respectively, that is the normal eye can see very distant objects clearly, but near objects only if they are at a distance greater than 25 centimeters from the eye. Again and again, the number is being repeated, and this is called the least distance of distinct vision. And power of the eye to focus the object far off, that is in the space, that is called the power of accommodation. The ability of the eye to see the objects from infinity distance to 25 centimeters from it is called the power of accommodation. So more literally, the power of accommodation means that normal human eye has tendency to focus the objects in the space, and that too especially, that is the stars and planets. Now, we come towards the position of object. If object is at infinity, however, mathematically infinity is undefined function, But infinity means in the space, that is in the fourth dimension. Parallel beam of light enters the eye, is least strained and said to be relaxed or unstrained. So whenever we say that eye is relaxing, it means that there is no variation on the retina or the eye is not receiving any light, that is not receiving any energy. However, if the object is at distance, at least distance of distinct vision, that is 25 centimeters, then eye is under maximum strain and visual angle is maximum. So when we keep the object at 25 centimeter, we find a good intensity of eye enters through the convex lens and it forms image at retina. We say that retina will be strained. Now it is not relaxed. So it is not unstrained now. The moment light goes to retina, it means it gets strained. And now we come towards the two figures. That is the left figure, relaxed or the normal eye. We are finding that the rays are parallel. They will fall on the convex lens, and from the convex lens, they will converge at a point on the retina. And in the right image, we are finding that is least distance of distinct vision is 25 centimeter. Object is kept there. And again, we are finding that converging rays, that is from a point, the rays will diverge. They will come to the convex lens. They will enter the convex lens and will converge to a point on the retina. That is called maximum strained eye. And next one is the limit of resolution of eye is 1 minute. That is 60 seconds. That is, two objects will not be visible distinctly to the eye if the angle subtended by them on the eye is lesser than 1 minute. Lesser than 1 minute means we are referring to an angle of 60 seconds. So you can remember that trigonometrically the unit of angle in sexagesimal system is degrees, minutes and seconds. One right angle will be 90 degrees and 1 degree will be 60 minutes and 1 minute will be 60 seconds. However, the French system is centesimal system in which we use grades. So here we don't use that. We are using only sexagesimal system. Now, the persistence of vision. As I have explained earlier, that retina has tendency to analyze the image maximum up to 1/16 seconds and minimum 1/620 seconds. So the persistence of vision of a normal eye varies from minimum 1/20 seconds to maximum 1/16 seconds. And we can see 16 to 20 images. That is what the tendency of the normal human retina. If the time interval between the two consecutive light pulses is lesser than 0.05 to 0.0 seconds, I cannot distinguish them separately. So what exactly we have done? We have divided 1 by 20 to get 0.05 and we have divided 1 by 16 to get 0.06. This fact is taken into account in the motion pictures. In motion pictures, we see the picture as well as we listen the sound. It is a simultaneous phenomenon. Now, in case of eye, following are the common defects of the vision. As I have explained you, one of the defect is called myopia. The other defect is hypermetropia. Then comes the presbyopia and then comes the astigmatism. So these are the basic defects. The lenses used for correcting these defects will be myopia, concave lens, that is diverging lens, and for that is the next one like hypermetropia, we use convex lens, and then for the remaining two, we use cylindrical lens, or we have to change the sphericity to particular angle.